For decades, the search for life on Mars has captivated our imagination. We've sent probes and rovers, all with a singular mission: find evidence that we are not alone in the universe. The prevailing strategy? Follow the water. This makes sense, right? Water is the lifeblood of our planet, essential for all known life forms. But what if we've been looking in the wrong places? What if life, tenacious and adaptable, has found a way to thrive beyond the traditional signs we seek? Recent discoveries suggest a bold new approach. Follow the salt. This isn't as far-fetched as it sounds. Turns out some of the most extreme environments on Earth, places where water is scarce, harbor life forms with remarkable resilience. These extremophiles, as they are aptly named, challenge our very understanding of what it means for a planet to be habitable. Could they hold the key to unlocking the secrets of life on Mars? Take the Atacama Desert in Chile, one of the driest places on Earth. This desolate landscape, with its scorching days and frigid nights, seems an unlikely haven for life. And yet, life persists. Deep within the salt rocks, hidden from the harsh elements, reside microbial communities that have adapted to survive on the edge. These hardy microbes, known as hygroscopic organisms, possess an incredible ability. They can extract moisture directly from the atmosphere. Forget rivers, lakes, or even underground aquifers. These tiny survivors have evolved to thrive in conditions that would spell doom for most life forms we know. The Atacama Desert serves as a powerful analog for Mars. Both are characterized by extreme aridity, high levels of radiation, and frigid temperatures. If life can flourish in the Atacama, who's to say it hasn't found a similar foothold on the Red Planet? This raises an intriguing possibility. Perhaps our search for Martian life has been too water-centric, overlooking the potential for life to exist in the most unexpected of places. Our traditional understanding of habitability revolves around the presence of liquid water. But what if, on Mars, the key to survival lies in the salt that blankets its surface? This is where our story takes an exciting turn. Remember those resilient microbes in the Atacama? They've adapted to survive with water as a thin film on salt crystals. Certain salts, known as hygroscopic salts, attract and absorb water vapor. What does this mean for Mars? These salts could create tiny hidden oases within their crystalline structures. Section 4. Deliquescence and efflorescence unlocking hidden water. To understand how these salt-loving microbes might survive on Mars, we need to delve into the fascinating world of chemistry. Two processes in particular are key: deliquescence and efflorescence. Deliquescence is the process by which certain salts absorb moisture from the atmosphere, eventually dissolving into a liquid solution. Think of those little silica gel packets you find in shoeboxes. They work on the same principle. Efflorescence, on the other hand, is the reverse process: the release of water vapor from a hydrated salt back into the atmosphere. Now here's where it gets really interesting. The relative humidity levels at which deliquescence and efflorescence occur can differ significantly. This means that there's a sweet spot, a range of humidity where a salt can absorb more moisture than it releases. Within this zone, microscopic pockets of water can persist, even in environments that appear bone dry. This is crucial for potential life on Mars. Section 5. A new direction. Targeting hygroscopic salts on Mars. So where do we go from here? Future missions should prioritize areas rich in hygroscopic salts. These salty havens could be harboring the very life we seek. Imagine a rover equipped with specialized instruments exploring the salt-encrusted plains of Mars. This is the future of Mars exploration. By following the salt, we might find that life has already found a way.